In this video, I'm going to be working a multivariable calculus quiz over absolute extrema. And this one's only got 2 questions on it. I think it's kind of a rough draft of a quiz I'm going to give in future years. But for this year, we were just working it in groups. And the first one is, okay, kind of like the example I probably worked in class. We've got a function we're trying to maximize on a region that's bounded by a horizontal line and a parabola. And you see we've got some multiple choice answers. I'm going to work this, kind of in some blank space because it's going to take a little bit. Okay, so the first step is going to be to find the critical points. So I'm going to take the derivatives fx, that's going to equal 3y minus 2, and fy, that will equal 3x minus 4. Okay, and critical points are going to be where both of these are equal to 0, so that would happen if x was, say, 4/3 and y was 2/3. Okay, so x equals 4/3, y equals 2/3. Yeah, okay, that makes a little more sense. I'm looking at it differently. And then I'm going to need my z-coordinate because that's going to be a candidate for the absolute minimum that I'm looking for. Okay, so z is going to equal, it's a little crowded. Zoom out a little bit, yeah. Z will equal 6 plus 3xy. All right, 3 times, well, maybe I'll just cancel off one of the 3's, and I'll say that's 8/3. Yeah, that's going to be the way to go. Oh, yeah, and I worked this one up part of the way earlier, and I definitely know that's what I'm supposed to do here. And then negative 2x is going to be negative, wait a second, negative 2x is minus 8/3. Okay, this is not what I got earlier, but I've looked at this for quite a while now, and I don't see any error, so I think it's all right. It must have been an error earlier. But either way, I'm going to see that I've got 6 minus 8/3, and 8/3 is definitely a less than 6 type number, so I'm going to say that this is a positive number, and I'll just keep that in mind. Looking at the answer choices, I saw a bunch of negative values, and I didn't see anything with any thirds, so I don't think that's really going to be one of, it's not going to be my minimum. Okay, now I need to check the boundary. So I'm going to start with the easier of the two pieces, this line right here. This is y equaling 4. And so I'm just going to plug in y equals 4. So really what I'm doing is I'm looking at f of x and 4. And that'll equal 6 plus 3 times x times 4, that'd be 12x, minus 2x minus 4 times y is minus 16. And if I put that all together, I'm going to have 10x minus 10. Okay, and so now, really, I've just reduced f to equal 10x minus 10 if I'm along that y level. Okay, and I'm really interested in when x is between negative 2 and 2 right there. Okay, so I think it's pretty self-evident that the minimum value of f, restricted to y equaling 4 is going to be where x is negative 2. So x equals negative 2, and I've got a formula for f right here that only depends on x, so that'll be z equals negative 2 times 10 is negative 20 minus 10 more is negative 30. Okay. And then, okay, the last part is checking on this parabola. And I don't know, I'll be honest, I got this one from the Publisher's Test Bank. And I worked it earlier, and I did not like the third-degree polynomial that we're about to get. But, this is y equals x squared. I'll just show you the technique. I might end up having to go to a Desmos window to justify something, which would make this not a very good no calculator quiz. But otherwise, it would just be really intensive on the computation because of the polynomial we're about to encounter. So I'm going to have f of x and y equals x squared. That's going to equal 6 plus 3 times x squared, okay, minus 2x and minus 4y, which is now x squared. So if I was to kind of write that in a more standard form, it'll be 3x to the third minus 4x to the 2 minus 2x plus 6. Okay, and this is not factorable. We don't really need it to be factorable. What we're trying to do is maximize or really minimize, I guess, for us, f on the closed interval negative 2 to 2, again, because it's only depending on x, and in this world here on this parabola, x is running from negative 2 to 2. So what we're going to need to do if we want to do that is kind of run a candidates test from AP Calculus. It's in a single variable case, and it's inside a larger candidates test, and that's why these problems are a little intensive. So I'm going to need the derivative. So I'm just going to say, yeah, I'm just going to say f prime, or maybe I'll just say, okay, I'm interested in where the derivative of this thing, 9x squared minus 8x minus 2, is equal to 0, because those will be candidates for absolute minima of this function that we're trying to minimize on the closed interval -2 to 2. And this thing is not factorable. Let me think about b squared. I didn't think about b squared minus 4ac. Okay, I just did b squared minus 4ac, and I got 136, which is not like the worst number ever, but it's not a square number, so I know that my zeros of this polynomial are not going to be nice. And I think at that point, that's when you really know. We're going to need to bring in some technology here. I don't know if this was from a pretty old book. I don't know. I don't know exactly what they were getting at. I added a couple of multiple choice answers, but we even looked at the original version of the question in the book today in class, and we did not see. We didn't see any way that you could like eliminate all the answer choices based on like the work that we've done up to this point or anything. So I'm not really sure what I'm supposed to be seeing here. I'm gonna go look at Desmos. Okay, there we go. So, all right, I'm seeing what I need to see now. All right, I have graphed this thing, and I can see that both of the extrema, the relative maximum and the relative minimum, are occurring at a place where the output is going to be a positive number. I've already found a place where the output is negative, so these are not candidates. So now I'm reduced to checking the value at x equals -2. I look at this and I think about f of when x is -2, I've already run that. That's where x is -2, and that gives me an output of -30. So I'm going to conclude that because I've checked the critical points, okay, I found that x equals 4/3 and y equals 2/3 gave me a positive number. Okay, I checked the boundary, the y equals 4 and the y equals x squared, and the lowest value I found along the boundary was -30. I know I've checked everywhere, and I know that -30 is my global minimum. Okay, so I'll just go ahead and say, all right, that's my conclusion, and I'm ready to move on. Okay, now we've got one. Find the absolute extrema, so maximum and minimum, of this function on the region bounded by the square with vertices at these 4 points. All right, so I'm going to start by drawing a diagram of the region. All right, so here's the region, and so first I need to check for critical points. So take my derivatives. Fx is going to equal 4y minus 4. And fy will equal 4y plus 4x minus 12. Okay, so this one's a little bit different from some of the ones we've seen recently. With this one, we're going to need to kind of like look at the easier of the two equations and be like, okay, well, the only way fx can equal 0 is if y is equal to +1. Okay. Otherwise, if y is not equal to 1, then fx doesn't even have a chance to be 0, and it's not a critical point, right? Because fx and fy are both going to be defined everywhere. So with that, fy equals 0 when 0 equals 4 times 1 plus 4x minus 12, which is going to be 4x minus 8. So I think x would need to equal 2. And so y equals 1 gives me x equals 2. That will give me this is like the only critical point. And okay, 1, 2, that's in, or 2, 1, that's in the middle of, you know, about right there. That's the critical point. So I'm going to check the value of f of 2 and 1. And I'll have 2 times y squared plus 4 times x times y minus 12y minus 4x. I'm going to kind of run out of room if I don't start doing some of this arithmetic mentally, and then plus 1. And so that's going to be 2 plus 8, feels like 10, minus 20 is going to be -10 plus 1 is looking like -9 to me. All right, and so that's the value of the function at its only critical point. And then I need to check the boundary. And, you know, I think I'm going to go over here and say, all right, this is y equals 0, this first piece, the bottom of the square. So that'll be my first substitution. F of x and y is constantly equal to 0 down there. So that's going to be 0 plus 0 minus 12 times 0. So negative 4x plus 1. That's, yeah. Okay, and that's nice. And so maybe I could say, and related to this, x is between 0 and 4. Okay, so the minimum I would have would be when x is equal to 4, right? Because it's negative 4x plus 1. So I would say the minimum is going to be at x equals 4, y equals 0, and z would equal negative 4 times 4 is negative 16 plus 1 is negative 15. All right, so that's a more negative value. So that's now kind of a better candidate for my absolute minimum. And the maximum value of f, okay, that would happen when I was subtracting the least amount. That would be at x equals 0 and y equals 0. That's going to give me 1. Okay, so far that is the maximum, but I don't think that's going to end up being the maximum. I liked plugging in y equals 0. That was kind of nice. Maybe I'll plug in x equals 0 next. And so I'll say, okay, next I'm going to look at f of 0 and y. And that's actually not going to be as nice as we want it to be. That's going to be 2y squared minus 12y plus 1. 2y squared minus 12y plus 1. Okay, don't love the look of this. Okay, and y is also running from 0 to 4 on this. Okay, now, let me think about this. Okay, probably it's only going to have one critical point. And yeah, I think that was my mistake. So I was trying to factor f, and that's just not going to be the thing to do right here. I'm trying to find the maximum and minimum value of f, which is really 2y squared minus 12y plus 1. And so I'm going to need to take the derivative, and that would be 6y to the first minus 12 equals 0. That would be at the point 0 and 2 would give me a local extremum. And then when I plug in x equals 0 and y equals 2, I will get 2 times 4 is 8. 8 minus 24 is going to be negative 16 plus 1 is negative 15. Did I already run that one? No, it's just happened again. Okay, and so that's not anything new. I should also test the endpoints. So that would be where y equals 0. Okay, x is equaling 0 this whole time. So when I've got y equals 0, then that'll give me an output of 1, but I already knew that, so I'm not even going to include that. And the reason why I didn't check the endpoints over here on this one is because it was a linear function. I just knew what the maximum and minimum was going to be, and that just wasn't going to be totally necessary because the f was like strictly decreasing as x increased. So I just, we knew. Okay, I checked y equals 0. Now I will check y equals 4. That would be where x is 0 and y is 4. 0, 4, and 2 times 16 is 32. 32 minus 48 is negative 16 plus 1, another negative 15. Okay. Then I have checked 2 of the 4 edges. So this is going to be y equaling 4 as x runs from 0 to 4. And I'm thinking, yeah, okay. All of this right here that I'm, just about to put a big circle around. Okay, or an oblong circle. None of this is really giving me any new information. I was already at negative 15. I already had a maximum of 1. So I'm going to make this much smaller and kind of get it out of the way. Actually, I'm going to get it all the way out of the way. So now I'm going to consider where y equals 4. So f of x and 4 is going to be, all right, 2y squared. That's going to be 32 plus 4xy. That'd be 16x. Minus 12y is minus 48. Minus 4x. And then plus 1. Okay, and that's going to be equal to 32 minus 48 is negative 16 plus 1 is negative 15. So I've got 12x minus 15. And this is, once again, f of x and 4 when x is on the interval 0 to 4. Okay, so the very maximum this would be when x equals 4. So x equals 4, y is also equaling 4, and z will equal 12x minus 15, so that's 48 minus 15. Ooh, 33? Yeah, that's 33. Okay, so I have a new candidate for my maximum. Okay, 001 is out. I've got something better. The minimum value of this would happen when x was 0, and so that would be 0 and 4. I may have already checked that and ended up getting negative 15. When x is 0, yeah, again, I'm going to get negative 15. That's not any new information, but I do have a new maximum. Okay, so, and that's still my minimum is negative 15, so I might get rid of the work up here now. Maybe this wasn't wise. Maybe I should have just like scrolled the page around, but you know, I'm going this far now. And so now I'm going to be checking the last one, which is x equals 4. F of 4 and y, that's going to equal 2y squared plus 4x is 16y minus 12y minus 4x is minus 16 plus the 1, again a minus 15 in there, so I got 2y squared plus 4y minus 15, and y is on the interval 0 to 4. Right, so the critical point of this one, the minimum location, because it's an upward facing parabola, is going to be where 4y plus 4 equals 0. That would be where y equals negative 1, so I don't even care about that. That's outside of my interval. That's just, okay, that's great for me. I'm going to test where y equals 0, 4 and 0, that's going to give me negative 15. I've definitely seen that already. And 4 and 4, I've already checked that too, so I'm just going to get rid of all of this. And I'm going to say, all right, the minimum is 0, 4, negative 15, and the maximum was 4, 4, 33. Oh yes, I got so wrapped up in that problem that I forgot that there was only 2 problems on this quiz. So that's going to be all for this video. Thanks for watching.